Okay, friends, it's nice to see you. Some of you did not finish the quiz. Some of you have a grade in the quiz. So the quiz was originally made out of 22 points. And not that you did bad, but I didn't want to bury anyone's grade. I'm sorry. So what I did is I graded it out of 22, and then I subtracted what you missed out of 30, made it out of 30, which actually was a nice curve. Okay. So that's kind of a good gig for all of you, I believe. If you need to, I'm going to offer this to you because I know it was a tougher concept. If you wanted to earn points back and it's already graded, you can come see me during one of your off periods. You are allowed to use any of my videos if you have one on your phone in your hood. So you can fix that, get more points. And if you need to finish it, I'll allow you to use your phone as well, using my videos to try and help you along with that. And then if you just need to take it, then just come in on an off period, you can use your phone. But if you didn't get it done, or if you weren't here yesterday, please make sure you have your phone, and then you won't get the opportunity to make it up because no one had the opportunity first to use their phone on it. Cool? All right. So, Geo, I gave this out. Don't worry. Only Swan has to have the whole thing memorized. You're going to use this forever, okay? All right. So let's just kind of like figure out things that we've been working on. We've been talking about confidence intervals, yes?
Yes.
So really what that is we started out earlier in the year, we talked about a normal curve, and we talked about you have standard deviations right and left that take place. And so these standard deviations have to do with how far from the average you would be as far as a normal curve. Okay? So that's what we've been doing. All really a confidence interval is talking about, hey, how confident could we be that information within a normal curve that might not always form an exact normal curve, but how confident would we be in order to encompass area? So when you're looking for the area, that's the inverse norm, and you plug whatever percent in, and it figures out what that area would be. The confidence interval would fall into this region. Okay, so it's somewhere on the standard deviation. So you're like, hey, how far away from the mean are we getting in order to accommodate a certain percentage of the data, and how sure we would be. And of course, the higher, if we said 99.9% accuracy, you're talking about you're going way far out to try and capture as far out as possible. We said we're 40% confident. We're taking a really smaller chunk of that area. So the area shrinks as the confidence interval gets closer and closer and closer to the mean is basically how you're looking at that. So today, we're going to be looking at the one mean t interval. We're not going to do the two-tailed. If you look at the sheet I gave you, it talks about the two-tail as well. Don't worry about two-tail. That's something for a different statistics class later in your life. We had some information that had come in from a student who had taken this class last year. Not with me, but they had Mr. Anderson because he was the only teacher of it. And the student had to take two different statistics courses, and is in their second statistics course this semester at CU. And the student's claim was because they had this class, they feel very comfortable with what they're doing. So it's a nice preparatory if you ever have to take further statistics. Whether you do or don't, I don't know. I don't know what your degrees are, and there's definitely things. So, hey, last day of masks, right?
Yeah. Let's just lift the mandate.
So it is quote unquote highly encouraged that everyone wears a mask, but it's not mandatory.
Are you going to wear a mask?
Taking a drink.
Nope. I won't have it. And I'm sorry if that offends you. I apologize. Am I old? Yes, I am. But I love you for that. I will tell you. So here's kind of the silly. If you've ever been to Arizona, you have been exposed to something far deadlier than COVID. No, it has nothing to do with insects. It has to do with a fungus that's in the soil of Arizona, and it's a disease called valley fever. And valley fever, if you've been to Arizona, you've been exposed to it. If you've been exposed to it, therefore you've built antibodies. Valley fever can hit you at any time, and it's very deadly. When we used to watch one of our 3 stations in Arizona, that's all we had on TV. There was a commercial that used to come on, and it was showing Arizona is a big agricultural state, growing lots of cotton, citrus, and things like that. And they would always show some farmer grading their field and a large plume of dust coming up, and the large plume of dust, depending upon how the wind went, would go over the Phoenix, Tempe, Mesa, Chandler, Gilbert, the metropolitan area. And the commercial would start out and it'd say, dusty, dusty, dusty. You live in Arizona, you have been exposed to valley fever. Here are the symptoms: excessive choking and coughing, shortness of breath, and how does high fever, all these different things. And it's this fungus that gets into your lungs that it will affect some people, and people who get it are screwed. Their life expectancy drops significantly, but this is something that you don't really hear about. If you lived in Arizona, you know about it. If you've ever been to Arizona, don't fear going to Arizona. It's just one of those things you'll be exposed to. So it's a pretty deadly disease, and it's a fungus from the soil. So whatever happened in Arizona in the ancient history that got into the soil that the farmers now plow their fields and the dust goes over the city, that's basically it. And living with a mother who is a hypochondriac, she'd hear about a tornado in Nebraska, and she'd say, "Get inside, there's a tornado in Nebraska." And it's like, "Oh, we're in Arizona, Ma." So I'm not sure how we survived living in Arizona for all the years we did.
Did you wear masks?
Nope. Nope, I was not a mask wearer. But all right, so the 1 mean t interval, and it says the standard error formula for means requires the population standard deviation. In most cases, it's simply impossible to know this value. For example, how would a researcher know the standard deviation of cholesterol levels nationwide? How would realtors know the standard deviation of all home sales prices everywhere? It's impossible, but fortunately, statisticians came to the rescue. They developed a way to use sample standard deviation in place of the population standard deviation. The t-distribution was created specifically to account for extra variability that comes with using sample standard deviation, and it's an estimator of the population standard deviation. So remember, as you go away from the mean, standard deviation. The t-distribution is shaped very similar to a normal distribution, and we'll explore this later. Okay, 1 mean t interval is very similar in structure to the 1 mean z interval, which we just did. And the t-distribution was created so that we can confidently substitute the sample standard deviation for the population standard deviation. Therefore, we use a t-interval when given the sample standard deviation. We need to calculate the t critical value and not the z critical value. The method for doing this will be discussed later. The margin of error, when you're using with t, you're going to notice that this is very similar to what we've been using. Okay? So this will come from your table, and this will be the my samples, the sample standard deviation, and then obviously n is the number of participants. for the population that you're talking about. Okay, so that looks very similar to the z. The only difference is they have t in place of z. Okay, again, this is where you use it. Not all your calculators will have an inverse t command. Some might, and you're totally welcome to use that, but this I will always have readily available for you. Finding the t critical value for any given confidence interval is a tricky task. Well, it's not really when you have the t table. Okay. Again, it talks about the gravity calculators don't all have the inverse t function, and then using that, you'll use the table. So if you go to the second page, you see that graph right there? You all have better eyes than me because they're much younger eyes, but that table's kind of hard to read. This one's a lot nicer to read. It's 8 times the size, so that's good. So kind of maybe put this in place between page 18 and 19 so you know you have that there. Okay? To locate the critical value, you need both the confidence interval and the degrees of freedom. Oh, that's a new term. Okay? You simply look up the corresponding critical value t from this table. The degrees of freedom is 1 less than the sample size. So the degrees of freedom is 1 less than the sample size. Okay, so if you had 20 participants, you are at 19 degrees of freedom. If you have 100 participants, you're at 99 degrees of freedom. Don't panic that they're all not listed there. Usually, the t-distribution is used when you have a smaller amount of population, and you can start figuring things out. So notice they have degrees of freedom of 1. That means you sampled 2 people, and then you can sit there and figure out the margin of error and the critical values from that. Okay? Example. 20 bicyclists riding along the Denver trail system showed an average speed of 18 miles per hour with standard deviation of 4. Okay, so 18 miles per hour, and then they had a standard deviation of 4. So basically, one standard deviation would be from 14 to 22. Okay? So think of it like that way. It says create a 99% confidence interval to estimate the average speed of bicyclists along the Denver trail system. The point of estimate is 18. Okay? Miles per hour. That's the sample mean. The proper setup for the margin of error follows. So MOE equals T star, which we talked about, S over root N. And they're going to come out with, so what they're doing is this. We're looking at a 99% confidence interval. So look on that table, go to the very, very top row where it says confidence level, and it says 60, 70, 80, 85, 90, 95, 98, 99, 99.8, 99.9. You still with me on this? So we're looking at for the column for 99%. Did you find it? Okay. So then it's going to say we had 20 bicyclists. So 20 bicyclists. I'm going to go 1 less than 20, so I get 19. 19. Find 19. Scroll over or go over on your row and find 99. Do you get 2.861? So that is your t value. So the t value, t star, is going to be 2.861. Of course, they gave it to you in the notes. Whoa, 2.8. It's got slow on me for some reason. 2.861. Okay? And then we go times 4. 4 is what? Standard deviation, right? Over the square root of all of our people. And if you went and did this math, you went 2.861 times 4, and then divided by square root 20, you're going to come to 2.56. Okay? So what I'm going to do with that 2.56, that's going to then be 18 plus or minus the 2.56. And this is going to tell you that go from 15.44 to 20.56. Okay? That means that we are 99% confident that if we tried to sample again people, that they are going to have a speed along whatever trail we were talking about, the Denver trail system, between 15.44 miles per hour and 20.56. Is it possible people are going slower? Yes. Are there possible people are going faster? Yes. But we're 99% confident that we're going to show this. Now, this is probably fictitious information. We're just going to trust that it's true. Um, but it's a different way of thinking about it. And again, I don't know if any of you have ever been on a bicycle on any of the cement trails like the one that goes along the South Platte River. I used to ride. I ride a bicycle almost every day in the summer. I love bicycling. I had a 1991 road bike that I rode from 1991 until about 2015. It was a Truck 2100. It was carbon fiber, Shimano 105 derailleur on it and components. When I bought the bike in 1991, the bike cost $3,000 in 1991. Okay, things have gone up in price. This is probably about an $8,000 or $9,000 bike now. I actually gave the bike to one of your classmates, not in here, but one of our classmates. He used to come in and get help all the time. And I said, hey, he told me he wanted to get into riding road bikes. I said, you know what, you can have my road bike if you'd like it. He goes, really? He goes, but it's 1991. I said, come look at it. If you want it, it's yours. I just want someone to ride it. I refuse to ride it anymore. The reason I refuse to ride it is I was cruising down Clarkson at about 28 miles an hour in a 30-mile-an-hour zone, and a garbage truck ran one of the stop signs. I laid it over and wound up underneath the garbage truck. I got lucky. There was really no damage to the bike other than a little on the pedal. It was a little straight, but that's about it. Scared the heck out of me. I got to a point going, you know what? People don't pay attention to bicyclists. So now I ride a cross trail, and I'm usually on the Highline Canal Trail and any of its little tributaries, including getting myself into trouble coming through Cherry Hills, going, I wonder where that trail goes. And then all of a sudden, security coming up to me from the neighborhood saying, why are you here?
Happens all the time.
Because the trail went this way. You're not allowed to be here. How do you know I'm not supposed to be here? We know. Okay, because I look like a big threat, having a water bottle, my helmet, my sunglasses, pair of shorts and a t-shirt, and my riding shoes on. And I'm a big threat. But I got asked to leave a certain Cherry Hills neighborhood because the trail went that way. So, and I'm like, there's nothing on the sign. And then like 2 weeks later, there was a sign, this is private property, do not enter unless you are an inhabitant of this neighborhood. I'm like, okay, they told me. So needless to say, one of our seniors is riding my road bike, and he was so proud to tell me that he's been riding it, and he said, Stirrup, do you know I got that bike up to 48 miles an hour? I'm like, yeah, it's fast. It's real fast. Which is fun, and I enjoyed riding. I've done all kinds of rides in my years. I did a ride back in the 90s when I used to ride with Arizona States. They had kind of a club team that was, did I get one of these? Oh, you know. This is the key distribution. So it's some of the rides I did rides from Tempe to Flagstaff. I did rides from Tempe to Tucson. I did rides from Tempe out to Parker, Arizona, which is on the Colorado River along the western border of Arizona and California. So I was pretty aggressively riding. But one of your classmates in Garrett Creek is now riding my bike, and he says it's pretty fast. The bike weighed 20.5 pounds. So it was light and it was fast, and it is fast according to that. So with that known, that is kind of the information. Is there any questions about this? Again, I hole punched it. I would think if you have this in a binder, put it between page 18 and 19. Maybe indicate that that little tiny graph on the page, top of page 18 is a larger version here. So that's what I have planned for you. Wanted to give you some opportunity to work on this. And again, if you needed more time on the quiz, or you wanted to improve your grade, you are welcome to come in during one of your off periods. You're welcome to use my video from last week, or I think it would be Monday, that would have been the review for it. So you're welcome to use that. So just bring earbuds. So page 83 and 84 is kind of what we're looking at for Monday. And if you have questions, let me know. Happy to help you. And let's see what else I got. And that's all I have for you for today. I dismiss you, but I'm not allowed to. No.